Let's suppose that we have a three-dimensional grid with the three axes of x, y, and z, and we want to find the distance in between the points labeled point 1 and point 2. And we'll find this by noting the relationships between their distances and how these distances can form the relationship between the total distance between 1 and 2. So first, just labeling their parts is distance A, and this distance is just the difference in between their y coordinates. So for instance, this length is the y coordinate of point 1, and this length is the y coordinate of point 2. So just the difference of that is length A. And using similar logic, we have point B, which is the difference between their x values, and we have point C, which is the difference between their z values. So then just labeling the relationships between A and B form this hypotenuse, which we can label D. And similarly, D and C form a hypotenuse, which we will label length E. Notice that length E is a distance that we're trying to solve for. So what we can see is how this forms a right triangle, and we know how to represent that in math just by the Pythagorean theorem. So we know that d squared equals a squared plus b squared. And similarly, we can note that E is a hypotenuse of the right triangle with lengths D and C. So we can also write that E squared is equal to D squared plus C squared. Now, we should notice that we can simply substitute in for this D squared the value that we have right here, since they are talking about the same variable. So this would transform into E squared is equal to A squared plus B squared plus C squared. And solving for E will be the square root of all that we have, which is A squared plus B squared plus C squared. Now, this is the length that we're trying to find. But notice, we could have simply found E as well if we just would have taken the square root of this value right here. But the purpose of using A, B, and C instead of D in this case is that D is defined as a distance, but it has the values of both a change in the x coordinate and a change in the y coordinate. So to make the math simpler and to form a general case formula, we use A, B, and C because each of these values represent the distance of only one axis. For instance, A is just the distance of the y-axis, B is x, and C is z. So since we have each variable accounting for one axis, then we don't need to have some other sort of arbitrary variable that accounts for more than one, because it just allows for a simpler case. So because it does this, then we could rewrite it as sort of more abstractly as the distance E will equal the square root of the change in y squared plus the change in x squared plus the change in z squared. Notice that this is the same thing as what we have right here, but sort of in a more arbitrary sense. So we found that the distance between two arbitrary points in 3D space is just the square root of each of the respective axes squared.